code analysis tools can help a developer understand code. One tool for code analysis is bitHound, which provides code and dependency analysis for NodeJS applications. On today's episode, we discuss how to use a code analysis tool, and we also talk about how to build one by breaking down the distributed architecture of bitHound's backend. This is a really interesting episode about a product that many developers are going to be using in the future, whether it's specifically bitHound or any code analysis tool. This is the type of tool that will help developers save time and avoid dependency problems in the future, or security problems, all kinds of other problems. If you're a fan of Software Engineering Daily, we want to know how to improve. Please take 5 minutes to fill out our listener survey. There's a link to the survey in our newsletter and on our website. We would love to know what you think. We want to know what you want to hear more of, what you want to hear less of, and as soon as we get enough respondents, we will stop hammering on the survey. But we really want to get a representative amount of data, and people still haven't really filled out the survey. I mean, many people have, but we want more. So we really want to build the best software podcast, so please respond to the survey. After a quick word from our sponsor, we will get to this episode of Software Engineering Daily. As a software engineer, you have tremendous leverage in the employment market. Every company needs software engineers, and these companies are all competing for you, the engineer, a scarce resource. But as an individual engineer, you don't have much insight into this incredibly opaque market. That's where Hired.com comes in. Hired.com assigns you a talent advocate who works to understand your needs and works to find you the perfect job. Go to hired.com/sedaily to try out the platform today and get a $2,000 bonus if you find a job. The companies on Hired compete for you, the engineer, and they make bids to win your talent. These are companies like Facebook and Uber, companies that we know are on the cutting edge of engineering because they've come on Software Engineering Daily to talk about their tech stack. I've used Hired personally, and I've experienced firsthand the ease of finding a well-paid, enjoyable job. This was way better than replying to LinkedIn messages from uninformed recruiters, and it was also certainly better than using a job search engine. To find a great job and support Software Engineering Daily, go to hired.com/sedaily and get a $2,000 bonus upon finding a job. Check it out. It would support the show. Now let's get on with the show. bitHound is a tool for Node.js code analysis. Gord, Tanner, and Dan Silivestru are the CTO and CEO of bitHound. Gord and Dan, welcome to Software Engineering Daily.
Thanks for having us. It's great to be here.
So this episode is about code analysis. What does that term mean, code analysis?
Well, code analysis in its most basic form is essentially programmatically breaking down the software that you're looking at. So taking the code, breaking it down in what's called an AST or an abstract syntax, and then being able to crawl that and try and expose a whole bunch of insights to help developers essentially do a better job. So that could be as simple as linting, making sure that stylistic guides are being followed. And then there's more complex things like looking for duplicate code or complexity within various code branches. And it expands well beyond that as well.
As developers, we give off lots of data while we are writing our code and when we're working on projects. And this data accumulates in GitHub repositories and across our test runs and when we open and close bugs. And as our data accumulates, it is building latent value. And I think bitHound helps to expose some of that value. So give me an idea of the value of this type of information that we are giving off as we develop applications.
Yeah, that's actually kind of the genesis of the idea for bitHound, was looking at all this data that we do generate as we commit to our repositories, as we comment our code, as we open and close bugs and issue trackers, as we run our tests, as we release software and build software. There's just a lot of data that is created as we work alone and together and on teams. I came from the call center software industry where data is king in that industry. It's all about call wait times. It's all about how long people are on hold, how many people are converting to a sale from a call. So taking the inspiration of that, and I always wondered, are we at a point when we can start to use some of this information that we generate as developers to build better software and better software teams?
Cool. Okay, so you mentioned using an abstract syntax tree to evaluate some, code or other information. Listeners may be familiar with the abstract syntax tree because it's something that we use to, parse our programming languages so that we can evaluate them and actually run code. Give me an idea of how the bitHound product actually works. Like what kind of work you're doing when you build an abstract syntax tree for somebody's code, and what you're assessing when you evaluate that syntax tree.
Right. So I think what bitHound does, it goes well beyond just parsing the AST to gain information, and to, like Gord mentioned before, in terms of the amount of data that's generated, and bitHound tries to think of the code also in a historic sense, right? So parsing the AST allows us to look for blemishes in the code itself, or structure issues. It's a much easier way to find things like duplicate code and complexity. But then coupling that information with the historic information that we get, that's generated by all of these developers and the teams that surround us, allow us to start assigning fragility scores to files. Basically, how often are they touched? For what reason are they being done? For like how many bug fixes are there versus actual work that's being done? So giving us kind of a bug-prone measure of those files. And when you take that and you couple it with the blemishes in the code, you can start assigning better severity scores on whether or not something needs to be addressed based on how fragile that piece of code is.
So when we think about NodeJS or JavaScript code versus a language like Java, I think of Java as a language that is better at catching your errors, and Java would be perhaps a language that not accurate? Okay. Just because exception handling and whatnot. How does that contrast with JavaScript, and why does it give rise to a need for a tool like bitHound?
Well, JavaScript, I love the language, and I'm sure Gord does as well. There are probably 1,000 different ways to write JavaScript, right? And there's good ways, there's bad ways. There are the good parts and the bad parts, and those do continue to evolve as the language itself evolves. JavaScript was designed in roughly 10 to 11 days by Brent and Ike, and I think one of the core needs for it was because they expected to have developers coming from all walks of life and all different past experiences. It needed to be able to be written in various different flavors. So someone who's coming from like the C world or the Java world, could actually relate to the language. And the language itself is dynamic, right? It's not statically typed. There are a lot of very simple mistakes that you can make, such as just a typo in a variable name. And the language won't stop you from doing that. It will just make that thing global and let you keep running, which could result in some very interesting bugs and issues down the road. So I think with JavaScript, there's much more of a monitoring and need for conforming to standards and having these kinds of continuous checks on your code, because very simple mistakes, it being a non-compiled language but an interpreted language, makes it such that you will catch those issues, but you won't catch them until runtime, which is probably, in the scale of where's your highest cost to catch a problem. It's production, then at runtime, and the cheapest one is when a developer is actually actively typing at the keyboard.
So we're talking about code analysis in the abstract, and a subset of code analysis is dependency analysis. Why is dependency analysis so important in Node projects?
Well, it's actually something we teased out as we dove deeper into working on bitHound, as well as what our customers were needing. We thought originally our focus was entirely on lint code style, like static code analysis. But as we were working with our project and working with other people's projects, we started to notice that the need to keep track of dependencies was a problem that we were having and that everyone else was having. The Node ecosystem is an amazing place where there are literally thousands and thousands of different third-party components you can use to build up your project. And keeping tabs on them is quite a chore that sometimes gets put off to the side as you're focusing on other issues. And so as we were writing bitHound and writing the dependency analysis for bitHound, we found we were able to give our customers and our users the ability to have someone else watch that for them so they can focus on more important things and have that ability to watch the dependencies for when they go out of date, when they have potential security advisories, when they're deprecated or they even start to be unused. We give them the tools to detect that and to update accordingly.
Let's get into the usage of bitHound. So let's say I'm getting started with a project and I want to use bitHound. Like let's say I'm the developer of AngularJS or Gulp.js. I think these are both projects that use bitHound. But let's say I'm just getting started with one of these projects and I'm like, okay, I want to get started with bitHound. I want this code analysis suite of tools. How do I get started and what is the onboarding process like?
That's a great question. Well, I mean, we try to keep it as simple as possible. I mean, our customers, being developers, managers, CTOs, are busy enough as it is, and having to configure a product before you even get a chance to get started with it is quite a chore. So really, you sign in or sign up for bitHound using Bitbucket or GitHub, just your credentials, your OAuth in. You're instantly presented with a list of all of your projects, private and public. All you literally have to do is click the big green button that says add the project. We instantly kick off analysis on it. We tie in webhooks so that we're aware of every new commit that comes in. And we integrate with your PR process so that as development continues to happen and as pull requests are being issued by your developers, bitHound can pass-fail those pull requests based on your criteria. So that's what it takes to just get started. And then very quickly afterwards, you could, one click at Slack integration. We also have a CLI so you can integrate with your build system in case you want to start failing your builds, should, say, a security vulnerability be detected on one of your dependencies, or, if complexity goes beyond a certain critical point.
So you've mentioned these other code analysis tools like linters. So as we're discussing kind of a use case of somebody getting started with bitHound, compare their experience with bitHound, what that would look like versus how they would experience older tools like linters or whatever other tools you're seeing people compare bitHound to.
Absolutely. So, I mean, it's an important note. I think we actually recommend to all our customers that they have linters implemented and configured for their local development environment. What bitHound does is it takes all of these analysis results and merges them together, and then augments them with other insights and other analysis that we do, such as understanding the fragility of certain files, whether or not they're bug prone. And the amount of work that happens on them normally. And what bitHound does is, rather than you having to go to 5 different places or integrate multiple command line calls into your CI or your local environment, and then making sure that all of your developers have it all configured the exact same way, bitHound provides you with an instant dashboard that highlights the things that are most important for your team to address. So essentially generate these priority items that are things that you really should be looking at, and give you recommendations on how to fix them. And then beyond that, we'd integrate into your workflow so that essentially your team and yourself can continue to focus on what's really important, which is your features, your tight deadlines, and allow bitHound to essentially be your security blanket, and making sure that the entire team is delivering to the same standards and the same styles, and isn't getting itself in trouble by accidentally shipping something that could put your product and your company at risk due to some security advisory or vulnerability that exists.
Mm-hmm. What we can do above and beyond just your standard linters is what we provide is context. Because we're running more than just lint, we're running more than just like your standard run-of-the-mill analysis. We take all of these data points that we're collecting and monitoring and bring them together for context as to what, like Dan said, what is most important? What lint in what file do you need to look at? What dependency is currently the one you should focus on? Which is just, that's what we can provide doing all the analysis and bundling together, which is quite hard with the standard tool stack for this.
And in a typical workflow, when are people finding actionable information with bitHound? Is it like I write some code, I ship it to the repository, and like my continuous integration tool kicks off, and then bitHound is somewhere in the continuous integration tests, or how does that work exactly?
bitHound is actually sitting quite a bit closer to the developer than that, right? So every time a commit goes in, bitHound goes to work on it, analyzes it, and then provides valid results. And if anything is found, then Slack message goes out, or if a developer then issue a pull request, then we can set pass or fail it.
Okay.
At the same time, the developers might not have done anything for the past week, but a new security vulnerability might have been detected on one of the dependencies that they have. So bitHound will proactively alert the developer and the entire team through either an email or a message into your Slack or HipChat to alert you to the fact that you are now exposed due to a vulnerability.
Okay, this is really cool. So now I'm starting to get it. Like, you're as a developer, you're writing software, but the velocity at which software engineering is changing, just the environment around it, and the velocity at which security vulnerabilities get discovered, that is all increasing. So bitHound is just like this layer where it's constantly sniffing out problems that could occur. You could almost think of them as like metagame changes that are occurring in the software development ecosystem.
Yeah, I think what's happening is we're approaching a point in time where there's more software being written. It's more complex. It's being written faster and at volumes which were unprecedented even a few years ago. So we're hitting that inflection point where it's getting to the point where you have to analyze software. The human cost and brain space of keeping on tabs of all of this is starting to approach an unmanageable level. And that's where services like bitHound, that's what we're jumping in to provide, the ability to alleviate some of that pressure you have on your already full day to keep on tabs of all this like information coming at you.
That's right. And if I might add to that, we tend to think of our development team as being made up of our core developers and our team members themselves, right? So, for an example, a team of 5, we team to think of ourselves and 4 other people that are building code. But if you're taking proper advantage of NPM and all of these external third-party open source modules, right? Your team is actually potentially made up of hundreds, if not thousands, of people, a lot of which you haven't vetted, and all hard at work at getting those components to continue to evolve and fixing bugs and performance issues and all those kinds of things. We no longer have the ability to, as individuals, keep tabs on all of that without automating that process in some way and fashion.
So now that we have an interesting idea of how bitHound works, I want to talk through an engineering problem that you guys have dealt with at bitHound. So in order to understand the health of an individual project, you might have to do analysis on thousands of commits to a project. And so there's so many things to look at. So if bitHound servers are running and they're trying to analyze all these different projects, the analysis of thousands and thousands of commits and all these lines of text, I guess describe the challenges that are associated with this problem.
It was an interesting problem, which starting day one, when we sat down and said, this is what we're going to build, I had a strong knowledge that this was going to be a distributed problem. We couldn't sit in one process and monitor every commit that's coming in on every file. There's a CPU cost, there's a time cost, there's an IO cost that is involved for analyzing this. As we all know, as we run our builds, we run our tests, we clone repositories, we run lint on them. We know there's time. You can feel that in your own environment as you're working. So scaling that up to the scale of which we are, where we're analyzing thousands upon thousands of projects a day, like hundreds of thousands of lines of code, you can imagine that you can't do that in one process. So from day one, we broke out into a distributed model to have all of our tasks be defined into smaller work sets that we could send out to random workers.
Describe the concurrency model a little more, the distributed model. Like, what was the granularity of concurrency, and how did you distribute that work?
Okay, well, yeah, concurrency, there are a few ways to do concurrency. There's the traditional shared memory model where you take some physical location on computer in memory or RAM or even in a physical file, and all your processes work together sharing it, thinking of passing the butter dish around at your kitchen table. It gets kind of tricky when someone tries to grab the butter dish before someone else is done with it. So that usually is a more complicated way to handle concurrency. You can end up with what are known as deadlocks or like other similar cases. Now, another case which we actually went with, which Node worked really well, was message passing, where rather than passing the butter dish, you pass messages about the state of the butter dish. So you can say, well, this analogy is starting to break down horribly, but rather than sharing a physical item, you're sharing messages and information about that item that people can do with what they will. So there's once I send a message out into the world, I don't care what happens to that message anymore. I'm not sharing something physical. I'm sharing information.
Okay, so you went with the message passing model. How did that fit around this problem statement of analyzing thousands of commits?
It worked quite well. There was a small problem because obviously there is a butter dish in the way of your repository. Like, we have to clone that somewhere. We have to have it physically located somewhere on disk. So that was kind of an initial issue. But what we were able to do, once we had that in place, it's just a matter of we would build up messages about files that we want to look at or analysis we want to run, and just send those out. And it worked really well with Node because of asynchronous I/O, the easy network stack. We chose 0MQ as a base messaging layer that allowed us to build a pretty flexible network and not worry about a lot of that networking hiccups as, okay, the server has to be up before the client connects, or what happens if we lose connection. All that was handled under the hoods for us. So we could just, essentially as easy as it is to write to an event emitter in Node, we could just fire events transparently in our code. And for all I know, it could be handled in my process, in a process next to me, controlled by a shared cluster manager, or in a completely different data center or a completely different machine.
So can you contrast that with how you would apply a message passing solution if you were working in Golang or Erlang or one of these other languages that we hear more closely associated with message passing architectures?
Yeah, a lot of those languages have a much more expressive concurrency set of primitives that you have available. JavaScript, by its nature, has one thread, so you're only ever doing one thing, where some of these other languages have the ability to do shared memory, shared state, a little more expressiveness around when you lock things, when you don't lock things. And Go with its Go routines has a really beautiful, expressive way of dealing with subroutines and sub-processes and message passing between them. So every language has its pros and its cons. I think what we got from JavaScript and Node was lack of choice almost, I don't want to say. We had kind of callbacks and asynchronous I/O, and we kind of lived in that small constraint box on how we could communicate.
It also gives us a great opportunity to, pardon the pun, but dog food our own product, right? Because we're fully built in JavaScript, and it allowed us to really put bitHound as a product through its spaces and make sure that we're building something that is providing value and is worthwhile for us, and that we could use on a daily basis.
And not to mention, there are good reasons for just using Node otherwise. Like you've said, Node is a great language for glue code, almost like Perl in some ways. Like, so what types of glue code, what types of scripting tasks do you find yourself using from Node?
That's actually interesting. Because we're a massively distributed system, we've gone with the idea that failure is almost the normal rather than the exception. Because we're dealing with hundreds of processes running across hundreds of machines, we have to expect that machines are going to die, that network's going to hiccup, that disk space is going to run out, that all these exceptional cases that you could run on like your standard install end up being not so exceptional. So with the idea of glue code, a lot of our tasks are essentially Node processes that are wrapped in an easy-to-use command line that we string together on via shell scripting or via other Node processes. So it just worked really well with the concept of the Unix-style small tools where you have standard in, you have standard out. So you're just passing information between them, and you can build it in a way that one part failing doesn't cause the rest of your tool chain to fail out.
And the lack of having state associated with each one of these processes means that if they do die and we never hear back from them, they just get requeued and they start working again, and the system essentially self-recovers.
So in order to architect this distributed problem, you built a master-slave architecture. Describe how that master-slave architecture works, and maybe if you could give a small example of, you've got 1,000, you've got a bunch of GitHub repositories, you've got a bunch of commits to evaluate on this architecture. How would the work be distributed up among this master-slave architecture?
Okay, yeah, it was interesting because that's how we started. We had like a main controller process that would grab a job such as analyze a repository. And this controller would start off figuring out how many commits are in this repository, clone it down, figure out all the files that we would need to look at, and then send out those other jobs off to like worker processes. And we quickly found that as we were performance tuning this, those workers would eventually need to split out jobs of their own. So there was never this concept of a master controller process anymore, that every single process needed to be able to spawn sub-processes back in the cluster to do their jobs. So for in our case...
Was there still like a hierarchy?
There is no hierarchy, actually. It's kind of a giant mesh-style network where anyone in the network can just send out a message or a group of messages and have them all be processed and sent back. So, for example, in our case of analyze a repository, first step, clone it, break it into the commits, send each commit out into a message. That commit can then further be turned into specific file tasks that get sent out, and so on and so forth. And it's a delicate balance of finding the granularity of the messages and tasks you want to work on versus the distribution of them. Because sometimes it's just faster to iterate over a list of 2,000 files rather than breaking them into bulk groups of 50 and distributing them. It's just a flexibility you kind of work with as you're playing with distributed systems.
Sure. And for this system, you built a module called Farm that is open source. Tell me about Farm.
Yeah, so Farm is the kind of that base messaging layer we have in all of our worker processes. It was an easy to use kind of DSL around the sockets of 0MQ and setting it all up. It was more of a thought exercise of opening source it up just so we could talk about what we do so people can look at it, see the examples. I know we're using it heavily. I'm not sure if anyone else is. But yeah, it was just the ability to have that common module that all our processes can use, and our other team members don't need to spend the amount of time that I do thinking about our network architecture or how to send these messages or what happens when one of them dies. So it's a nice way. One of the cool things that came out of it was the idea of our global event publish subscribe system that was really interesting because we're all familiar with the event emitter in Node where you can publish and subscribe messages in your process. With Farm, in which what we were able to do, we built that into a global publish subscribe. So every single service and process in our entire network can publish and subscribe messages across all machines. So we use it a lot for our analytics monitoring to kind of keep state on the system to kind of go, okay, well, I've worked on this many tasks today, or we'll have a command we call census, which we will fire out. We'll send a command line census, and it sends a message out to every single process and just asks them to fill out some information. They'll report back on this is what I'm currently working on. This is how many things I've done. And we have a long form census result that comes back from every single worker that is currently in the system. We can use for tuning or discovering workers that could potentially in a condition where we need to restart them.
When you launched bitHound initially, you went from having your distributed environment running on a laptop to a distributed environment running across hundreds of boxes. Describe the difference between bitHound as it worked locally and what happened when you launched it to production.
Yeah, it was an interesting story. As we were developing with the thought of distribution, I remember it was the first JS Conf we kind of came in and sponsored. And the system would kind of run on our laptops, on a couple of our Linux dev machines we had. And we made a few assumptions about state so that repository we clone. For example, when we were working on your code, we don't keep any of your code. We just keep metadata about it. So we'll clone a repository, analyze all the metadata, and delete it. And as we were working on this, we were always saying, oh, well, I'll clone this. And then all the other processes had the ability to go, oh, well, is the repository currently existing somewhere I can access? Yes. If not, I'll reclone it. So if you imagine a repository coming in on your local machine, you clone it once, you have 10 workers that are all on the same machine. All 10 of those can do the easy, oh, well, it already exists, I don't need to reclone it. When you're going across hundreds of machines, which we were for our production environment in JSConf, that case of shared state, which we heavily assumed and worked nicely, all of a sudden every single project would clone hundreds of times, which you don't really get to experience until you start actually distributing the code.
Certainly. It's an interesting story. Another thing I've heard you mention is that you use Vagrant to bridge the gap between your dev and prod environments. And we have the founder of HashiCorp coming on the show in a couple of weeks. So I'd love to hear more about Vagrant. How do you use it? How does it bridge the gap between your dev and prod environments?
What Vagrant gave us, so for those people who are just hearing this term, Vagrant is a simple way to build and provision virtual machines on your local dev environment. So you can define in a simple file 3-4 different machines, their roles, and some scripts to run to provision them. So the way we use Vagrant is rather than developing on our MacBooks or our Linux dev machines, we use Vagrant to create 3 to 4 virtual machines that are then running the same OS as our production environment in the same configuration. And using the same scripts as when we're starting up a new instance in the cloud or we will run those same scripts over and over as we start up these virtual environments locally. And then that gave us a local environment running the like proxies in front, the same SSL, the same load balancers, the same situation where you have multiple workers that have been provisioned a certain way. And it allowed us to hide all that from our developers. So our designer front-end developers upstairs can still work in an environment that is exactly like production on a smaller scale without having to spend their time realizing that configuring Mongo to allow remote connections needs a certain couple weird tweaks. The whole idea was simplifying the onboarding process for new developers and existing developers, and for keeping the parity between production and local development so that we're less surprised about how certain architectures work in the real world.
So I'd love to talk a little bit more about the product high level. So currently you're focused on Node.js. Do you plan to expand bitHound to other languages?
Expanding bitHound beyond Node.js is definitely on our roadmap. We made an internal commitment to both ourselves and our customers that we're going to continue to dive into Node.js and JavaScript to really be able to provide and expose very deep insights into what's going on. Like Gord touched on it before, but it's not just static analysis inside of a dashboard, but it's really being able to divine enough information to provide context around the results that we provide, so that the developers all the way through to project managers and CTOs can actually drive decisions and assign work based on the context surrounding the results. So once we feel we're almost there at this point with bitHound, there's a couple more places to dive into. But then, yes, other languages are definitely on our roadmap.
Do you see a light at the end of the tunnel in terms of the Node.js work? Is it like where you implement one thing and you see 5 more things you need to do?
I definitely think it's the latter. And it's not to say that, bitHound is lacking, but the environment, the language, and Node itself, and, with that, all of the things that are associated with it, such as NPM, continue to move forward at a breakneck pace, right? So, JavaScript as a language is evolving year over year with new implementations, and new language features that get implemented, and we need to make sure we stay on top of those. As the whole ecosystem matures and as Node has truly become enterprise ready, there are other considerations that go with that. Everything from long-term support to just better practices in terms of how to manage all these massive amounts of third-party code that we're consuming on a daily basis. So I think if we did nothing but Node support, we definitely would still have our work cut out for us for the next few years for sure, just because of the speed at which the industry itself is moving.
Well, you certainly put the hardest part first. I imagine once you get Node.js right, you kind of get the flywheel spinning. Then you can be like, okay, well, let's go hire a Ruby expert, and then we can have somebody that does the Rails stuff. And Ruby, as fast as it's moving, I get the sense it's moving slower than the Node.js community. So presuming that you have the best practices in place from the Node.js implementation, you'll be able to do the Ruby on Rails implementation much more easily.
Yeah, that's correct. But I think it goes even beyond that. I think one of the things that we've realized is really diving into this level of analysis is that a large percentage of the analysis that you do to be able to gain the right context in terms of the insights that we provide to our customers so that they can know what actions to take. So essentially actionable insights are actually language agnostic. Right, like looking at a file to see, how heavy is the churn on it, whether or not it's bug prone, looking at other dependencies and where they're being used, and what does that mean from an impact to your project when we recommend that you upgrade a particular dependency because there's a security vulnerability, right? If it's used in one place, maybe you're lucky, maybe it's a 5-minute update. If it's used in 100 places and you more than 2 versions behind, right? So there's breaking changes there and a whole lot of touch points. Maybe that's a week-long exercise. So I think we wanted to make sure that we implemented, that kind of depth of analysis inside bitHound, knowing full well that a lot of it is language agnostic, because that would give us an opportunity to later move on to other languages with the same depth of insight in a relatively short time span.
You mentioned the term bug prone. How do you identify bug proneness in a line of code or a repository?
The quick answer is magic. No, there's a lot of context that we add as we are working on projects. Right now, it's just a kind of a little bit of like word stemming matching on commit messages, tracing back to what issues are open and closed versus sentiment analysis of commit messages. We can kind of determine, usually there's keywords you'll use when you're fixing something versus adding a feature. And then just using that in the context of all your projects and all your commits and all your files, you can kind of tease out the language that a team would use to determine if they're fixing something versus if they're adding or tuning something.
So what are the biggest challenges that you guys are working on at bitHound right now?
I think, one of the biggest challenges obviously is just keeping up with the industry and the pace at which it's moving. But I think our biggest challenge as a company, which we continue to work on, is providing that context that we talked about, right? It's essentially trying to get bitHound as a service and as a software program to try and perform the same job as you would expect a senior developer coming into a project, looking over the code, looking over the history, checking out the blame, to really understand what needs to be teased, what needs to be changed to get the project, really moving forward smoothly. So the biggest challenge is really getting bitHound to work and act like a valued member of your team in terms of the insight and the context that wraps around that, rather than just being a dashboard with some numbers and some alerts. That's probably the hardest part. It's trying to get bitHound to act as a human software developer in its analysis.
I'd love to get some insight into the business, kind of the business of bitHound. Also, like, how do developers know that they want this tool, or do you have to put it in front of them and say, "Hey, this is an awesome thing, use it"?
I think the answer is a little bit of both. So we've talked to quite a few senior developers and working CTOs and VPNs, right, where they're actually still coding. And for them, bitHound serves the initial function of a validation of a gut feel. They're like, yeah, I knew that was a problem in my code. Now I have an objective third party telling me about it, and giving them the added benefit of being able to align their entire team to deliver to the same standards, and making sure that the more junior members of the team are aware of the impact of various actions that they take, such as which dependencies do I include at what state, what does latching on to a deprecated dependency mean for us. And then on the other end of the spectrum, we've had developers as well kind of just checking bitHound out, not really sure what it is all about, and then using it as a guide to improve themselves as developers, because we expose things that when you're first starting out in this profession, not too many schools teach you about. And so there's some that we need to show the advantage of bitHound too, but once they see it, I think it becomes quite clear and they get very engaged. And then there's others that have told us that they've been looking for a tool like bitHound for a while, knowing that there was a gap in their development process and their team dynamic.
Did you guys bootstrap, or did you raise money, or what's the foundational story?
We raised money for this startup. We started off with the intent of bootstrapping, but we had a successful exit prior to this. We built a company called Tiny Hippos, which was acquired by BlackBerry. And then as we went through talking to investors early on, which if there's any startups out there listening, please do that from day one of your company. So that way you have a story that continues to evolve with your investors.
Yeah, so you talk to investors before, even before you're actually ready to raise money.
Absolutely, because that way, by the time you are ready to raise money, they already have a graph plotted, a storyline that they can lean onto, and they're not just getting to.
Because they invest in lines, not dots.
And that's right, exactly. And they invest in people and they invest in teams. So as we started talking to our investors, we had a bunch of very early commitments to invest right off the bat. Part of it was our historical success. Others is just they really loved the idea and have personally felt the pain at some point during their careers that bitHound was trying to solve. And so, yeah, we did raise 2 small seed rounds to get us to where we are today.
Cool. So what's in the future of bitHound?
Well, bitHound's goal, and maybe even raison d'etre, if you want to call it that, is to be that indispensable solution and framework for companies to manage their entire software development process. So not just looking at the code and what it is and individual commits that developers are doing, but really helping you manage everything from the very beginning of a project all the way through to deployment and continuous deployment, and be able to give you deep insights, not just into the code, but into the cadence of your team, the performance, what areas need to be improved, and just how can you better manage the software delivery process within your organization.
Okay, one thing that has been coming up at an increasing frequency on this show is the build versus buy debate is becoming really interesting because they're just like I think Gord, you mentioned this, like the pace of software is just going so fast that there are just so many tools that you can buy that will improve your process, and it becomes this trade-off of like, are you willing to pay some money to solve this problem quickly so that you don't have this problem anymore? And it seems like it really is this evolution in how software engineering is taking place, where you can just buy these components and they just do what you need them to do. Do you guys get that sense also, or is this kind of a trend that I'm imagining?
It's actually kind of interesting because we had a customer kind of come to us as we were like, they're trying it out, and we were kind of saying, well, why don't you convert and give us your credit card, start paying us? And it was I think a CTO of a startup, and he's like, well, you know what? I can just do this myself. I can run a few scripts. I'm just going to put in my CI. I don't really need this. And we're like, I said, okay, well, we're $59 a month at the lowest tier, which is the tier you are at if you were to pay. How much time is it going to spend you to build and manage this system that would do what bitHound does?
And what is your hourly rate?
Exactly. Is your hourly rate like less than $1 a day for your developers? Then maybe, yeah, you can save some money. But the reality is you sometimes forget that sending 2, 3, 4 of your developers for a week hack project to build an amazing code analytics solution costs you a lot of money. And you're probably, after that week, you've spent enough to have a 5-year subscription for bitHound.
Exactly. And on top of that, that's the initial build. There is a lot of effort involved with keeping up with the evolution of the language and, everything else that goes with that. So I think a lot of our customers are finding that it is remarkably more cost effective to just engage with a service like bitHound rather than building it internally. We have talked to several companies, and we've had some converts where said, yeah, we used to have our own set of command line tools to attempt to do what bitHound is doing, and it was constant maintenance. And the maintenance could just be updating all these NPM components, but switching over to bitHound meant just clicking a green button and then a blue button, and then we were done, right?
And I imagine many of your customers are startups, technology companies, and there's this strange narrative in the business landscape these days that it is risky to be a business that is built on startups selling to other startups. And I think that this narrative kind of gets overblown and gets misinterpreted. But I'm curious to see. I'm curious if you guys interpret that as like any sort of risk to the business, or how legitimate you think that sort of narrative is. Like, oh, we're due for this downturn that is going to lead to all these startups selling to startups crumpling.
That's a great point. I think as a startup, you owe it to yourself to really understand not just the market landscape and the competitive landscape, but who your customers truly are. We all make assumptions early days in terms of who we think is going to buy our product. And then as you go through and start selling it, I think just like a diversified portfolio when you're investing your own money, you don't want to go all in high risk, high tech stocks. So you want to make sure that your product does appeal to the small to medium sized enterprise that's established already at a minimum beyond just the startup world, and make sure that you have a legitimate path to get to enterprise, meaning the Fortune 1000 companies, and what are the value propositions that your project and product provide to entice the larger folks. So a lot of startups start by selling to startups or the small enterprise because it's easier to do that whole automated conversion to paid. You don't need as much sales staff to pick up the phone and calling. But understanding how your product can provide value beyond the small enterprise, even though it comes with longer sales cycles, it also comes with larger dollar figures. But it helps your company then be established and then survive any potential downturn in the startup ecosystem.
Cool. Well, yeah, it sounds like a good place to close off. Gord and Dan, thanks for coming on the show. This has been a really interesting conversation spanning code analysis and investing and all this different stuff. And yeah, I'll be following your product closely.